Okay, so today we're dealing with right triangles and Pythagorean Theorem. Do you guys remember what the Pythagorean Theorem is? What? Very good. A squared plus B squared equals C squared. Okay, so in right triangles, we have the Pythagorean theorem of A squared plus B squared equals C squared. Adele, move back, please. Okay, if a triangle is a right triangle, then the sum of the squares of the lengths of a leg is equal to the square of the length of the hypotenuse, and also the converse is true. So that means, here's my triangle. B would be a leg, A would be a leg. The legs are the sides that make up the right angle. The C is the side that's opposite the right angle, and that's the hypotenuse. So what this theorem states is if triangle ABC is a right triangle, then A squared plus B squared equals C squared. It also says the converse is true. The converse is just switching it. You can also say if A squared plus B squared equals C squared, then triangle ABC is a right triangle. So you can use this if you're told you have a right triangle, and you can use it to prove it's a right triangle. Both work. Okay, you can prove the Pythagorean theorem using similar right triangles. We'll do that later. We'll come back and I'll prove that to you using our similarity that we've been dealing with. But let's just practice using the Pythagorean theorem. So it's asking us to find the missing side. So we're first going to label A, B, and C. A is always the shortest leg. So this is the shortest side, so that's going to be the A value. B is the longer leg, and C is always the hypotenuse. So we're just going to plug this into the Pythagorean theorem. A squared plus B squared equals C squared. So we're going to have 12 squared plus 15 squared equals the C squared. It's going to give me 144 plus 225 equals C squared. $144 plus 225 is $369. Now what? Square root both sides. So I'm going to get C equals the square root of 369. Or I'm going to round it to the nearest tenth, 19.2. Now again, when we take the square root of a number, we usually have a positive and a negative. But in this case, we're dealing with a length. So I can't have a negative length. I can't have the negative 19.2 length of that side. Okay. So that's why we just leave it as the positive. Any questions over that? Okay, we're going to do the next one, B. Same idea. I'm going to label A, B, and C. This is A, B, and the hypotenuse is C. So then we're going to get 7 squared. This time we're finding B, so B is squared. And it equals 10 squared. So 7 squared is 49. Plus B squared equals 100. We're going to subtract 49 from both sides. I'm going to get B squared equals 51. I take the square root. And I get B equals the square root of 51. Or 7.1. Any questions? Okay, you guys do the next one in your pairs. Okay, we're back up here. Okay, so most everyone got that. You would have had 8 squared plus 8 squared equals c squared. So 64 plus 64 equals c squared. 128 equals c squared. Then square root, and c is going to equal the square root of 128, or 11.3. Mm-hmm.
How do you get the decimal?
On my calculator?
Yeah. No, like how do you get the answer?
I plug in my calculator.
You plug it in, you just go, what is the square root of 128?
Can you plug? Yeah, can you plug? Okay, show it to me. I'll show you how to get the decimal on it. 8 square root 2.
So on a test, will we need 2 answers or just one?
Okay, try it now. Okay, we're back up here. Okay, now we're going to apply it to a problem. To satisfy safety regulations, the distance from the wall to the base of a ladder should be at least 1/4 the length of the ladder. Did Drew set up the ladder correctly? So I don't think you guys can see this in your notes, but this side length is 2.5, and this side length is 9 feet. Okay. We need to find the length of the ladder, which in this case is the hypotenuse, to my C value. Let's start by finding the length of the ladder. So we have 9 squared plus 2.5 squared equals the c squared. So this is 81 plus 6.25 equals c squared. That's going to be 87.25 equals c squared. We're going to square root, and I'm going to hit c equals 9.3. Okay, so c equals 9.3. It didn't ask me for the length of the ladder, though. It said, did it meet safety requirements? So the question is the ladder 1/4 the length of the ladder, which was 3. I don't know why I have parentheses there. I shouldn't. Length of 9.3, 1/4 the length of 9.3 away from the wall. Okay. As a decimal is what? 0.2, that's a quarter, right? 25 cents. Now what we want to know is 9.3. How is the relationship between the length, the distance from here, which is 2.5, and 9.3? So we're going to put the 2.5 on top over the 9.3. And I'm going to see what that length is. Or that's when I divide that. What's that ratio? I've got 0.26. Oh, 27? Yes, thank you. 0.27. So is this at least a quarter away? Yes, it's more, right? It's more than a quarter. It's 0.27, not 25. So yes, the ladder is correctly. Did you set the ladder correctly? Yes. Yes, because it is more than 0.25 or 1/4 the ladder's length away from the wall. Any questions over that? Okay, now we're going to go on to special right triangles. These special right triangles will be used in all the upper math courses. You will see this in trig. It's really important for trig. It is, you'll see it in pre-cal. You'll see it in next year in Math 3. Okay, so these are the special right triangles that we're going to introduce to you today. Okay. The first one is a 45, 45, 90 right triangle. In a 45, 45, 90 right triangle, the legs are congruent. Okay, so this side is congruent to this side. That means it's an isosceles triangle. Okay, two sides are congruent. Okay, that also tells you that the base angles are congruent, which is how I know that 45 and 45 are congruent. It also then says that the hypotenuse is square root 2 times the length of the side. So my ratio here is square root 2. So our ratios are 1, 1, square root 2. That's how they're related to each other. So let's just practice some basic ones. If this side was 5, what would the length of the hypotenuse be? Okay, let's review. The hypotenuse is square root 2 times the length of the leg. So if this side is 5, what would this be? 5 times 5 times, is that 2? Square root 2. So if this is 5, this is 5 times square root 2. That makes sense? Okay. If this is 8, the length of the leg is 8. What's the length of the hypotenuse? 8 times square root 2. Okay, if this side is 10, what's the length of the hypotenuse? 10 times square root 2. Okay, if it's 7.5, what's the length of the hypotenuse? 7.5 times square root 2. Okay, now let's go in reverse. What if I gave you the hypotenuse was 10? What would the length of the side be?
2.
Okay, what did I do to get, if I went from here to here, what did I do? From the side to, very good, I should divide. Okay, so when I was giving you the side, I multiplied by the square root of 2. So if I'm going to go babackwards, what am I going to do? divide by the square root of 2. So if the hypotenuse is 10, what would be the length of the side be? 10 by the square root of 2. If the hypotenuse is 8, what is the length of the side? 8 divided by square root 2. Does that make sense? So you're either multiplying by square root 2 or dividing by square root of 2 to find the length of the sides. Okay, just depending on what I give you. Okay, now, what if I have a 30, 60, 90? This is another type of special right triangle. Okay. In a 30, 60, 90 right triangle, the length of the hypotenuse is twice the length of the shorter leg. The leg is square root 3 times the length of the short leg. Okay? So this is my ratio. Here's my shorter leg. It's the 1. It's the 1. So it'll be 2 times S. Okay? And the longer leg is square root 3. Does that make sense?
No.
They're just ratios that you need to memorize.
Okay.
Okay, so it's nothing like we didn't come, okay? It's a 5 times, which is 10, right? So if this is 5, the hypotenuse is 10. If this is 5, what's the length of 3? Okay, if my side length is 8, what is the hypotenuse? 16. What is the longer leg? Okay, if I gave you the hypotenuse, if it was 14, find PR and PQ. Square root 3, and the hypotenuse is 2. Those are my ratios. Is which one is the shortest leg here? Okay, if you're not sure, okay, I think this one's a little obvious, but the shortest side is opposite the smallest angle. So here's the 30-degree angle. PQ and PR make up that 30-degree angle. So the side opposite it is the one it doesn't touch, which is RQ. So RQ goes, makes sense? Because that's the shortest side. Does that make sense? Okay. Now, the leg is the square times the square root of 3. So which the square root of 3? That makes PR the hypotenuse. So you should be able to come up with the length of the sides right now. A little confused by that. So I'm going to show you another way to do it. If you can't see the ratio together, okay, and do this in your head. And we've kind of already set them up. Okay. Here's your proportion to find PQ. I'm using what I gave you guys, the 1/6 and Q. We're going to cross multiply and do 6 times the square root of 3. And that gives me 10.4. Okay. Now I can do the same thing and find PR. The one with just 6 equals 2/PR. And cross multiply times 2 for that. We're good? Okay, I'm going to have you guys do UT and VT. Do F in your pairs. These are ratios. 1, 0, 3, and 2. That's square root of 2. So this should just be square root 3. I don't need to do that. Yes.
Yeah.
We gotta write the first part down. And then pair them up. What goes with what? What's the shortest leg, what's the middle leg, and what's the high part? Perfect. Okay. So this would be square root 3 times 2, right? Then divide by 2.
No.
Oh. It is. Okay. So since these both are the square root 3, so this is 9. Okay. So then you put these cancel out in your 9, so it's 9, right? It's quite a bit. Are you adding something? Yeah. There's no adding here. There's all multiplying, right? You're dividing by this word. Okay, you had to do it. Okay, so some of you guys should be able to do this without even doing the work. Okay, so you're going to start with writing out the ratios. 1, square root 3, and 2. Okay. Okay, UV is my 1 because it's the shortest side. Okay, UT is 9, square root 3. And then TU is the vertex, or is the hypotenuse, the longest side. Okay, seeing as though it's 9 square root 3, it should be easy to find UV. Because whatever UV is, all I had to do to get TU is to multiply it by the square root of 3. So anyone know what UV is? UV is 9. What is TV then? 18. If you're not sure on that, okay, all you have to do is do the proportion. Here's my proportion I'm going to use. 1 over uv is equal to square root of 3 over 9 square root 3. Well, what's square root 3 divided by square root 3? 1. Anything divided by itself is 1, so those will cancel out. And I'll get 1 over uv is equal to 1 over 9. And then I can cross multiply. 1 times 9 is 9. uv times 1 is uv. Okay. Once I find uv, I should be able to find tv because it's twice as big, right? So tv is just the 9 times 2, which is 18. Any questions over that? Shh. Okay, next one. Now we're at a 45, 45. So we have to use the ratios for 45, 45. Go back up here and look. 1, 1, radical 2. So the sides, to get the hypotenuse, I just have to multiply by this radical 2. We are on G. Our 1, 1, radical 2. Okay, so remember when of my side, all I really have to do is divide by the square root of 2 to get to my side, right? Okay, if this is confusing, then I set up my proportion. 1 over kj, I'm going to use this part right here. Square root of 2. Oh, look at, again, square root 2 over square root 2. That becomes 1, right? So my fraction, or my proportion now is k12. Kj times 1 is kj. So kj is equal to 12. But kj, so the two legs of an isosceles triangle are congruent. So kj equals 12, and so does kl then. Any questions over that? Okay, you guys do h now.
Yeah.
I know, I just fixed it. Oh, no. Why'd you change it? Okay. You can go back and forth, but just, so she just asked me. You changed it. You got it back to the 732. Okay, so go to mode. Okay. Arrow down. It's classic in math. Math prints just give you the radicals. Classic gives you right? Just arrow over to arrow over and okay, class, we're back up here. Okay, you guys are done with my calculators, okay? Okay, so again, my ratios are 1, 1, radical 2. Okay, my side length is 7. That means my other side length is 7. Right? Because they're both the same. 1 and 1 is the same, right? So if I gave you that, so that means this is my side length, which is xz, which equals 7. Then yz is just my side length of 7 times the square root of 2. So it's yz equals 7 square root 2. Or if you want to plug into the calculator, you can leave it just like it is. 9.9. Any questions over that? Okay, next one. Alejandro needs to make both the horizontal and vertical supports, AC and AB, for a ramp. Is one 12-foot board long enough for both supports? Explain. Okay, so when I look at this, I need to see if these two sides together will be more or less than 12 feet. Yes?
I did have a question. So on H, would we have to keep it at 9.9, and would we be able to round it up to 10?
Into those sides. Okay. So we're going to do our ratio 1, square root 3. This is 30 degrees. This is the 60 degrees. And this is the 90 degree. Right? Hypotenuse. Opposite the